Welcome everyone to another learning session. How many of you are new to cloud computing? You can say yes, no. Okay, many people. Today's session is not specific to Azure. I want to assume that my students do not have any technical knowledge at all. So I always have a pre-session called Cloud Computing 101, which is not Azure specific. Even module 1 of the AZ 900 will talk some of it, but the structuring is different. I conduct this before every other session as a general special session called Cloud Computing 101. So this session will take you through the essential things that you should be knowing before actually starting to work with cloud computing in general. And in case if you have any doubt, please feel free to ask now, or you can at least write down these terms and you can search in Google, and then you can ask doubts later also. But for a successful cloud computing journey, you need to understand these things without fail. At least you should have a basic understanding. And if you have this understanding, many of the things that we'll be learning later in our Azure Fundamentals or AZ 104 or other certifications will be much easier, because you know how all these cloud computing and all these things work behind the scenes. That said, are we ready to get started with our cloud computing 101 session? And I need all of you to be fully active throughout the session to get the most out of it, irrespective of your time zones. If you really want, you can make an exception for a day, maybe getting up early or maybe sleeping late. You will definitely get this recording later, but you will not get the opportunity to ask doubts live and get it clarified. And feel free to ask any doubts. And I am ready to stay back after the session until everybody say that, okay, they are clear with the topics, and everybody say that, okay, I have learned something new today. Our objective is not to make you just certified experts, but it is to make sure you are job ready experts, people with knowledge who can contribute in job successfully, and also you can successfully pass any exams. So passing exams is the easiest one. So whoever has attended our classes either live or YouTube, and then did all the practice in Q-Talk, all of them have passed the exams with a very good mark. But passing is just one thing. My objective is not to just make you pass a certification exam, but make you really job ready and make you understand what cloud is, and get yourself ready for becoming a cloud architect in future. So let us get started with today's topic, cloud computing 101. Getting started with no prior or relevant knowledge of cloud. Since I am assuming you know nothing at all about IT or cloud, you can just ask whatever you feel like. The only takeaway you should have after this session should be taking away some knowledge about cloud computing. And if somebody asks you what cloud computing is, or what this Azure is, or what this AWS is, or what any cloud computing provider is, then you should have a ready answer with you. So today we will learn about a lot of things, starting from history of computing, starting from bare metal to server virtualization, containers, container orchestration. What are these things such as Docker or Kubernetes that you hear around, see around? Then road to cloud and beyond, how the traditional data centers are related to cloud, and what is this serverless, advantages of cloud computing, effect of capex and opex, and some of the important features of cloud: high availability, scalability, the terms scale out, scale up, elasticity, fault tolerance, disaster recovery, low latency. As we will see later, most of these are not actually features of cloud, but these are actually good features or desired features of any applications that are available online. And by using cloud computing, you get these much easier and much cheaper than otherwise. So thought of the day, it is the person who stops studying merely because he has finished school is forever hopelessly doomed to mediocrity, no matter what may be his calling. The way of success is the way of continuous pursuit of knowledge. This is from a book called Think and Grow Rich by Napoleon Hill. You have taken up that decision to come out of your comfort zone and then learn something new. This is a cloud computing 101 session. That means you are going to start learning from scratch, and then you have decided to learn something new in your free times or making time for this. In any case, you have decided to continue learning after your regular college, and then I want to appreciate it and also believe that this is a very important step in learning about in becoming successful in today's competitive world. Quickly know your teacher. So I'm an author, architect, and tech evangelist. I'm a Microsoft certified trainer. I have a couple of master's degrees on cloud computing and data analytics. I have some good IT certifications across Java, .NET, AWS, Azure, IBM's tools, a lot of things. And I've worked with companies including TCS, SAP, Ariba, Software AG, VMware, Society General, etc. And still working as a principal architect. I have been a speaker at many meetups and conferences and webinars. And webinars are something that happened or started to happen after the lockdown and the pandemic. I've taught many students on cloud and Java. And I have written a few books, and one of the book has got this award of best 8th cloud computing book of all time. And I'm still writing. I want all of you to be part of my writing journey. And whoever seriously contributed towards the review of the book AWS Security Cookbook, which got this award, all of their names were also mentioned in this book, which is published in almost all countries through Amazon or through O'Reilly and through Pact. And have some Azure certifications, including but not limited to a DevOps engineer expert and Azure solutions architect expert. And I'm a Microsoft certified trainer. Okay, so that's it. Everything about me is done, and then we are going to get started with our cloud computing learning journey. History of computing. I'll try to keep the terms very simple for you today, so that you get to know things from a very basic perspective. And if you have any doubt, feel free to ask me. Bare metal machines, you can consider it to as your laptop or your computer at home. And this bare metal machine, normally you will be the only person who will be using it. And if you have family members, you will be using it. Generally, a practice is to create different. So in many families, we don't create different usernames or passwords. We just create a user. We just create one user, and then everybody shares it. Otherwise, if it is a little more techno families, then they might create different usernames and different users, so that everybody logs in with their own user, and that too at their own preferred time. But in an environment where multiple people who do not know about each other want to share a computer or a resource, you cannot have this coordination of time, that now I will use, now you will use, and all those kinds of things. And you need to have some software manage all these things behind the scenes. So server virtualization came into picture. Through server virtualization, a physical machine or a physical host machine, what we call as bare metal machine, can have multiple virtual machines. Okay, so these virtual machines will look as if they are independent machines to whoever is using it. So if you log into that virtual machine, you will get a feeling that, okay, I'm the only one who is using it, because you see everything just like you will see in your other operating system, because this virtual machine will also have an operating system on of its own. So the advantage is a single physical host machine can have multiple virtual machines, and these virtual machines all can share the computing resources, and there will be a software that is responsible for all these sharing and caring, because the software needs to make sure that if resources are available, then this particular one of the virtual machines in the host machine can use those resources. And also this virtual machine should not be overusing resources and not giving resources to other people. Some of the resources may be overcommitted, and people may use it when others are not using. So there is a lot of logic happening behind the scenes, and all this logic is done by a software called as hypervisor. And hypervisor, you have two kinds of hypervisors that are available. You have type 1 hypervisors and you have type 2 hypervisors. With type 1 hypervisor, your bare metal machine will have a hypervisor, and then on top of that hypervisor, you will have a lot of virtual machines. So these virtual machines will be managed by this hypervisor, and these virtual machines will have their own operating systems. So if you keep aside the hypervisor thing, your physical host machine will directly have virtual machines, and those virtual machines will have operating systems. That is one way, and that is the type 1 hypervisor way of doing things. And you also have type 2 hypervisors, which is mostly used for testing, development, or even simulations. In type 2 hypervisor, your bare metal machine or host machine will have an operating system, and on top of that operating system, a hypervisor will run virtual machines. So these are type 2 hypervisors, and type 1 hypervisors are the ones that are of prime importance to cloud computing. So now you are into a stage where you have a single physical host machine, and then that machine has multiple virtual machines. And all of these virtual machines, as I mentioned, will be looking like a different machine. So it has an operating system. So starting and stopping of those virtual machine will also take the same time as the starting and stopping of a computer, more or less, based on the configuration of the system also. But in certain cases, we need more faster way to start and stop these machines for use cases such as serverless. What do you mean by serverless? So serverless means you are no more worried about creating or managing even virtual machines. You just use the service, and behind the scenes, whenever you are using a service, it's a container or it's a virtual machine, whatever supporting that service will come up, and after you use or after you do not use for some time, it will go back. So in such scenarios, you cannot have a virtual machine, a normal virtual machine starting and stopping, because imagine your visitors are coming to website and then you are starting a virtual machine. It will create a delay, a bigger call start time. So all these terms, the call start time and serverless and all, we will see in detail in one of our future modules. But for now, just understand that there are many use cases where you cannot be, it is not okay to have the delay of starting virtual machines. That is one problem. How long you have been a software engineer? We have people who are freshers from school. We have people who have been working for a few years in IT. We have even people who have been working for 10 to 15 years and then now planning to change their track. If you have been working for quite a long time, then you definitely may have faced the issues I used to face when I was a developer initially. Whenever we as developers used to write code and then give to QA for testing. So the QA is a quality assurance team or testing team. Developers will create code or software and then give for QA to test, and then after that it will go to another environment, maybe a pre-prod or UAT for testing, and finally it will go to a production. There are other stages I'm not considering, but in each of these stages, whenever people are testing it, they will tell, okay, it is not working in my environment. Then these developers will fight that, okay, it is working in our environment. Sometimes when it goes to production, it will or it will not work, and then you have to reproduce it. Sometimes reproducing it is a nightmare because of some small configuration change in the environment. And then somebody came into the picture, containers. Okay, containers are a way to encapsulate your environment, and then you take the environment itself to other phases of software development. So you encapsulate your environment during development, and then the same environment is taken to QA, same environment is taken to UAT, same environment is again taken to production. So now you cannot say that it did not work in my environment or your own environment. That argument is over. This, I think, this was one of the example. Even one of the most popular container products, Docker, gave during their initial talks about explaining what Docker is. A container packages all software components into a single deployable unit and is often compared to a shipping container. You can imagine having a ship full of items without any kind of shipping boxes, and the nightmare you will have segregating them when you reach the destination. Or in other ways, so think about the easiness you will get by segregating things into different containers and then putting it into the ship rather than putting it all together. Value best understood with the works on my computer problem experienced by many software developers. Containers are lightweight alternatives to virtual machines. But there is another advantage. So there are two advantages. Right? One, it encapsulates everything and then solves the works on my computer problem. Basically, it encapsulates the environment. And second, it is a lightweight alternative to virtual machines. And Docker is one of the most popular container product out there. So one quick question to all of you. Do you know which company created Docker? Many knows, and also some answers telling Docker Inc. Now it is managed by Docker Inc. But initially the company name was not Docker Inc. Okay, Bharat has mentioned it correctly, .cloud. Okay, and then Docker became very popular. So what was the next problem? Managing Docker or managing containers became the next problem. Few Dockers, few containers was easy. But when you have hundreds and thousands of containers in enterprise companies, managing all those features. So we mentioned a list of features of cloud computing that we'll be seeing in detail later. To make sure that list of features, high availability or fault tolerance or disaster recovery, all these things to work for this large number of containers, you needed one more other tool for container orchestration. And container orchestration is nothing but orchestrating these containers. And Kubernetes, or in short, people call as KAS, because there are 8 letters between the first K and the last S. So Kubernetes is one of the most popular container orchestration tools. Kubernetes originally started as an internal project at Google and later was made open source. Kubernetes can be used for the management, scaling, and deployments of containers efficiently. Kubernetes as a service is available on most clouds, EKS on AWS, GKE on Google Cloud, AKS on Azure. So who manages Kubernetes now? Another question. Who manages the Kubernetes project now? Okay, I can see many answers, Google, but Google was the one who created it. Okay, so Bharat has mentioned it, Cloud Native Computing Foundation. So road to cloud. So data centers. So this picture may not be very appropriate. So what is a data center? It is some place where you will have a lot of servers that in turn contain data. If you search for data center Azure, then you can definitely see more of Azure's data center or data center AWS for AWS data centers. I had a website around 15-16 years back. During that time, cloud computing was not so popular or not available to people. It was just web hosting providers. So what is the difference between these web hosting providers and today's cloud? Can anybody tell me? Do you think the data centers are different from cloud computing? Or can cloud computing work without data centers? Okay, I had given, some people interestingly said yes, but I had given the clue initially itself, right? If you search for data centers Azure or data center AWS or GCP, you will get the data centers of these cloud providers. So anybody can create a data center if they have enough money. Cloud providers also have created. So the difference between traditional data centers and cloud computing is that With cloud computing, these data centers are provisioned for end users with some automation, or it should have a few properties. One is on-demand provisioning. On-demand means whenever I need to have a resource on cloud, maybe a virtual machine or any other machine, I should be able to provision it whenever I need, and I should be able to stop using it and stop getting built whenever I want. With traditional hosting servers, you had some of them had some money back guarantee and all. Otherwise, you have to take a service, maybe 1 month you get the money back, and then you can use it for a duration of 1 year, or some of them provide monthly billing. But that was it. That was the duration or minimum duration you have to commit. But with cloud computing, it could be just hours. I want to just try out a virtual machine. I can start it and then I can stop it whenever I want. It is automated and on-demand provisioning. Nobody is going to sit behind and then allocate these resources to you. Everything is automated. You don't have to worry about it. So even cloud computing uses data centers. Otherwise, also you can use data centers. So instead of manual provisioning, you have automated and on-demand provisioning. That is the first quality of a cloud computing data center. And then in generally, most clouds are pay per use. Basically, you pay only for whatever you use. Have you heard about these terms called capital expenditure and operational expenditure? A capital expenditure means the initial investment that you need to make or commit. Operational expenditure means the monthly or yearly expenses you pay based on your usage. So with cloud computing, you just pay per use so that your capital expenditure is much less. And with traditional on-premises data centers, you will have to set up that data center. For that, it will cost you a big amount of money. In summary, over traditional data centers, a lot of software work has been done to make it on demand and automated so that anybody can create a resource or kill a resource as they want, and only get billed for whatever time they use that service. Isn't it wonderful? So now anybody can actually start a startup with any good technology stack, and then if they are not successful, they can just kill off those servers whenever they feel like, or they can put it in backup mode. There are a lot of opportunities, but this was not the case sometime back. Before cloud computing, people had to invest a lot in getting this hardware and provisioning them, and if their startup or idea do not click, then they are at a big loss. So now that is why more innovations are coming up these days. This was also one of the things I suggested in our intro session, right? So cloud computing is one thing that you can use to create whatever you want, maybe a pet project. So whatever you do is on the same environment or same infrastructure that any big company or enterprise use. So whatever you do on cloud is actually real world. And then you have a lot of abstractions. So whatever we were telling about this cloud computing until now, at the virtual machine level, that is the first level, right? You have physical host, and on top of physical host, you have virtual machines. So that is the first level of abstraction. That is generally referred to as infrastructure as a service. And then you have platform as a service, where your platform for your development or platform for your database is provided to you out of the box without worrying about infrastructure, without worrying about installing this software on a virtual machine. You can just start using it without worrying about managing the virtual machines. What are the problems when you manage a virtual machine? It is just like any other operating system based computer, right? So you have to update it. Actually, I recently saw a forward in one of the WhatsApp groups, and I think in Facebook also. Let me know if you have also seen this. So now now it is set to be that a new variant more powerful than whatever all the other variants are coming, and then you may have to do one more dose or one more update of the vaccine. So and then it was told in that post that okay, it is similar to Windows updates. Okay, how many of you have seen a similar ad or WhatsApp forward comparing this variants and vaccine doses to this Windows updates? Okay, so similar to similar to how Windows updates will make your systems ready for newer attacks. Vaccines are supposed to do the same. They will make sure you are prepared for this kind of virus attacks. So all those things are abstracted away from you when you go to another layer called platform as a service. So if you are developing code, you can just develop code. You don't have to worry about even installing your particular runtime, maybe your .NET runtime or Java runtime or a Java server or PHP runtime, whatever it is supported by your cloud provider. You don't have to worry. You can just start using it. That is one advantage of platform as a service. And if it is a database, you don't have to install a database. You can just start using it. Then there is another layer called software as a service. Software as a service is something that you use as a end user. Your Office 365 mail or your Gmail, any of these things, you just configure and use it. You don't have much control about how it is being developed. But behind the scenes, it could be developed using infrastructure as a service or platform as a service or even serverless. Behind the scenes, it could be anything from a developer perspective. But from an end user perspective, it is a software as a service. And then you have newer ones such as a container as a service, function as a service, backend as a service. So we'll see some of them today, and all throughout our journey, we'll be learning deep about these things, and you'll be talking about these things, and overall we will be all learning about these things thoroughly. The more you know about these things, the better you will be able to understand and grasp whatever you are going to learn in future classes. So that is why I always believe fundamentals should be strong enough, and it has to be done in an environment where you can clear all your doubts. Sometimes you may not be able to ask doubts because you don't understand what it is. So you can just say that, okay, I did not understand, please repeat it again. So that is how fundamentals should be learned. Once you have very strong fundamentals, everything else you can learn in a much easier way, either on your own or with an instructor, whatever you prefer. So quick question to check whether you are sleeping. Which expenditure model should you use for migrating all the virtual machines to an Azure pay-as-you-go subscription? 1 operational, 2 elastic, 3 capital, 4 scalable. Further classes, we will have live quizzes. It will not be like this. It will be in a beautiful tool. To get a demo, you can go to quizandtalk.com, and then in the front page, there is a demo of the live quiz available. Varieties of answers, elastic, operational, scalable. Okay, so expenditure model. Which are the 2 expenditure models in this list? It is operational and capital. I had already told, right? Capital expenditure or CapEx, operational expenditure or OpEx. So these are the 2 expenditure models. So elastic and scalable, we will see shortly. They are desired features of an application that is running on cloud or on premise. It is operational, right? Or OpEx. Okay, so capital expenditure means you pay upfront or you make an investment like buying or setting up a data center. But operational expenditure means paying monthly or yearly based on whatever you use. What about electricity for a data center? Is it CapEx or OpEx? Okay, I have mixed answers, CapEx, OpEx. Majority of you are telling operational. Whatever I asked you is a very vague question. Setting up electricity for a data center is CapEx. You have to do the wiring, you have to get the connection. There are a lot of steps. But paying monthly bills or monthly electricity bills are part of OpEx. This heading called cloud features is actually a bit misleading. These are not actually cloud features. So these are desired features for cloud, as well as these are desired features for any application. High availability. So tell me, what do you mean by high availability? So whenever you need a service or whenever you need a data, it should be available. Simple terms. And in general, this availability, high availability and availability SLAs. What is SLA? Service level agreement. So these SLAs are mentioned in nines of availability. Say 99.99 means 4 nines. 99.999 means 5 nines. Sometimes there will be 11 nines. Sometimes there will be 16 nines. So tell me, 99% availability, is it a good thing or a bad thing? Again, we have answers: good, bad, bad. It also depends on many factors. So the answer is depends. But in general, do you know 99% availability in a year means how many days of downtime? Okay, some people have mentioned up to 3. So even 3 days, imagine that you are so many of you are part of a Facebook group, right? Imagine that 3 days your Facebook or WhatsApp is down for 3 days continuously. But for some businesses, it may be okay. So the answer is depends. And also when you hear these SLAs, they will say this SLA is for monthly SLA, means monthly it could be 99, or it will be yearly SLA, means it would be yearly, it will be 99. So you have to calculate. And then availability is still okay, but what about durability? This is not mentioned here. Even if there is a delay in getting your data, but still you want your data to be there, right? You don't want your data to go away. So generally durability is a lot important, and that is where any cloud provider will have a lot of redundancy options. So you will have options to spread your data across one data center, or across multiple data centers, or across multiple countries. I'm not using the terms, correct terms such as availability zones or regions and all, because we have not learned it. We will learn all those terms specific to Azure in module 2. But you'll have a lot of flexibility from your cloud provider. And another 2 important terms: fault tolerance and disaster recovery. How many of you understand these terms, fault tolerance, disaster recovery, and their difference? Let me give you an example. I have deployed my application in 2 regions or 2 countries. And first country server got down. This is scenario 1, okay? First country server got down, and immediately I switch over to second country or second region, and with little bit of time it starts working again, and things are back to normal. This is scenario 1. And then scenario 2, I have this instead of my data centers in 2 different countries, I have it in the same country or same region, and only one of them goes down. But due to my routing capabilities, the other one continue to support the application. This is scenario 2. So scenario 2, is it fault tolerance or disaster recovery? Okay, so option 1, scenario 1, where across region it is actually disaster recovery. 2, within your within region, within country, where you have multiple data centers and one continuing to support, is fault tolerance. Fault tolerance means even if some of the servers go down, your application will continue to run. Disaster recovery means your servers will go down, but it can come back up and then start supporting the users again. And you also have options within Azure to bridge those gaps. Don't worry, we will be learning all these things, but the purpose of this initial Cloud Computing 101 session is to introduce you to a lot of terms that can help you learn all the other things much faster. So now comes another 2 terms scalability and elasticity. Imagine that I have a e-commerce platform. Okay, so like Amazon or Walmart or Flipkart. So I have a e-commerce platform, and then I'm planning to do a sale. Okay, and this sale, whenever this sale is happening, I'll have more requests coming to my application than usual, and then my application should be able to sustain it. So my application should not go down when that request come. It should add more servers and support it. So that adding more servers automatically is called as elasticity. And that the whole thing about the application continuing to run with the additional capacity is called as scalability. Okay, so elasticity in a way supports scalability. What about global reach and latency requirements? If your application needs to be used by certain countries or people from certain countries or regions, they may have a compliance requirement that only the data of our people should reside in only our data, our region. And if you only have a data center in your country or your city, then for most normal businesses, it will not be feasible to suddenly go to another country and create a data center there. Right. So a cloud provider can definitely help you because they will have data centers in almost all regions. Azure is said to have the maximum number of regions across the globe. So you can choose whatever data center region you want to select based on that particular compliance requirements. Again, latency requirements, which is similar to global reach. When you set up data centers on faraway places, there will be, so what is latency? How many of you understand what latency is, the term latency is, and how many of you do not understand? Let me ask you in another way. Which is good, high latency or low latency? Okay, low, everybody knows it. So latency means the time taken to make a request and then response to come back, right? So if it is far away, okay, if it is like far away, it could take a lot of time. But then cloud providers have services such as content delivery networks or CDNs that can cache data near to your location. Or you can have your data deployed into multiple locations based on your customers' location preferences. There are different ways. You have a lot of flexibility on a cloud. And agility. How many of you have heard this term called Agile? Previously, we had something called as waterfall. In simple terms, Agile means you are open to change. So in traditional infrastructure-based, in traditional data centers or your on-premises data centers, how easy was it to change a purchase decision you made? You purchase set of hardware for X amount of money. Then you realize that, okay, this is not what I want. I want a different set. It is much difficult, right? So once you take a decision in traditional data centers, it is similar to waterfall model where you are stuck with whatever you have done, or it is the cost of change is very high. But with cloud, you can just stop that service and start using another service. Stop that virtual machine type and start using another virtual machine type. It is as easy as that. So agility is another advantage of public cloud. And then predictive cost. What do you mean by predictive cost? So most of the cloud providers will have their own ways to predict cost. For example, in Azure, you have Azure pricing calculator. Pricing is a module of its own, module 6. I will show all these things in detail. But for now, you can get an estimate of how much you will be charged based on all the factors. You can select regions, you can select any discounts, everything you can select, and then you can see how much you will be charged. So that is a normal pricing calculator. And also people migrating from on-premises to Azure Cloud has another calculator called as TCO calculator, total cost of ownership calculator. So these calculators will help you predict cost accurately, and we will see them in module 6 in much detail. And finally, security. Do you think which is more secure, on-premises or public cloud? This is a question of debate also. Some people have said on-premises, some people have said both are secured. What is cloud for us is on-premise for the cloud provider, right? For Amazon or Azure or somebody else, it is on-premise for them. It is on their premise. So it is on-premise from them. It comes down to who is managing security, who is taking decisions. So this cloud providers will be able to get the best of people that are available in the market, the best of the engineers to secure their infrastructure, to take decisions about securing their infrastructure. But may not be the case for many of the startups or data centers that are new, because they generally focus more on development efforts rather than on security and even reliability and all the other things. In many cases, you will be just okay with the security that is, or better with the security that you get for the behind the scenes infrastructure for many of the cloud providers infrastructure. The only thing is you will be worried about whether what will happen. So these are general doubts, right? What will happen if the cloud provider looks into my data? That is where things such as keys come into picture. You have Microsoft managed keys, you have customer managed keys, you have customer provided keys. We will see these in detail, I think in 104. We'll just touch upon in 900, but we go into these things in depth in 104. So there is a lot more to learn, but for a manager who is taking decision, he do not have all this knowledge about how things are secured behind the scenes. So he will not be able to effectively communicate these things to stakeholders. That is why most companies these days, including the current company I am working, has made it mandatory even for managers, tech managers, people from sales, people from business, to have at least Azure Fundamentals knowledge and certification. In case if your company is using Azure, then there is high chance that Microsoft has already given you vouchers, and you can freely take it by just going to the certification registration website. You can click on discounts button and just enter your company email. You may get a verification code to company email just to make sure that this is your own email. And once you enter it, you will get to know whether you have that discount or not. Okay, so coming back, everybody, do you understand all these terms now? High availability, fault tolerance, disaster recovery, scalability, elasticity, global reach, latency requirements, agility, predictive cost security. If there is at least one no, I will repeat. Are these only features of cloud? As I mentioned, all these features you can get in your on-premises also, or most of them. But what is the difference between using it on cloud and using it on premises? These features. What is the primary difference? So it is about money. If you have unlimited money, then it does not matter whether you do it on premises or on cloud. Each of these, if you take, you will get an example. Just take the example of a disaster recovery. You need to have minimum 2 servers, right? One for primary and one for backup. Yes or no? And at a time, how many of these 2 will be running? 1. So even though you need only one of them, at any point of time, you will be paying for 2 of them. But in a cloud, you will have to pay for the storage. That is a different thing. But for the compute, you don't have to pay for both, right? There are also options where you pay for both, where you can read from both. Then along with disaster recovery, you also get high availability. But in general, if in a normal DR scenario, either one of them will be running, and in that case, you have to pay only for one in case of cloud, and you have to pay for both in case of on-premise. And scalability And elasticity is a very big example. Consider the same example of a sale happening on an e-commerce portal. Imagine that now today I need 100 servers, and during the sale I need 500 servers. In on-premises, what is only the option left for you? Buy those extra 400 servers for that sale. And what can you do with that with those servers after the sale? You can't do anything, right? So selling hardware is not that. It is not like real estate where you get more money. You definitely lose money. And if you are keeping it for your next sale, then you are wasting that hardware resources for all those other 364 days. Okay, so here also you can definitely do it, but cost is a major concern. Same is the case with the global reach or others. So just a recap for all of you. High availability, ensuring an agreed level of operational performance, usually uptime. Scalability is the capability to adapt and perform well under an increased or expanding workload or scope, also referred to as dynamic scalability. Elasticity, allocation of required resources to meet current needs. Scalability is generally achieved through elasticity. Fault tolerance, ensuring that servers or services remain available even if some fail. Disaster recovery, maintain or quickly resume mission critical functions after a failure. Low latency, ability to access services faster through internet, maybe using CDNs. So if you are listening carefully, what is the full form of a CDN? Content Delivery Network. And there are many CDN providers. Even within Azure, Azure gives you the option to choose between Azure or other external vendors such as Akamai and all. Some more exam notes. Capital expenditure is initial investment such as buying fixed assets. Operation expenditure is ongoing costs, including annual costs. With on-premise, these features means the more hardware that will be used only when needed. But with the cloud, these resources are provisioned on demand. In high availability, performance and uptime in response to increasing demand is considered. With fault tolerance, only uptime in response to a failure is considered. In fault tolerance, service continues after failure. In disaster recovery, service may be interrupted but recover faster. Scale up means replacing servers with more capacity ones or increasing its capacity. Scale out means adding more servers and processing in parallel. So tell me one thing, horizontal scaling, is it scale up or scale out? Horizontal and vertical. Horizontal means scale out. Vertical means scale up. Vertical scaling means you are adding more powerful resources. Maybe you are increasing your CPU configuration, or you are increasing your RAM. All this comes under vertical scaling or scale up. Scale out means, or horizontal scaling means, adding more servers of same capacity and all of them taking up requests in parallel. So in cloud, both are supported, but the core kind of scaling in cloud that makes all the benefit is which one? Horizontal scaling or vertical scaling? Okay, so it is horizontal. So there is a question, can you please repeat scale in and scale out? Okay, so it is, so scale up means adding more RAM or CPU to your existing computer. That is a scale up or vertical scaling. Horizontal scaling means adding more servers and all of them parallelly taking up a request. That is horizontal scaling or scale out. So in cloud, we saw that Flipkart example, or we saw that other example with Walmart and Amazon, right? Whenever you have that sale, even in cloud, you cannot go and change the RAM. What you do in on-premises or cloud is add more servers during that sale to handle the request, and then remove those extra servers after that sale. So now tell me, is it horizontal scaling or vertical scaling? Horizontal, right? Clear? Everybody, 100%? Okay, thank you. So there is a question, but then we need to install apps, network connectivities also to be taken care. Yeah, so that is where other software such as load balancers and DNS and all will come into picture. So it will be the same set of software. You'll have a template. Imagine that you have a template, and using that template, you can spin up a new virtual machine. So all the software are installed in this template. So you'll learn many things as we move forward. And then regarding network connectivity, in general, nobody knows when we learn about networking. So we'll be briefly touching about networking in 900. But when we go to 104, we have three modules back to back on networking, where we'll be learning all about or most of the things about networking. And further, if you want to learn deeper, then you have AZ 700 full of networking. So in simple terms, for people with no background to understand, you will not be directly going to a virtual machine. You'll be going to some software such as load balancer. And this load balancer will know how many virtual machines are behind the scenes, and it will hit to each of them. And how these load balancers work behind the scenes is a very interesting problem to discuss. So it is not part of Azure discussions, but we do such discussions as part of our CSE Cafe discussions. Basically, you have things such as consistent hashing and many other techniques that people use for this. If you are interested, you can follow CSE Cafe activities. So there is another question: is scale up applicable to on-prem and scale out applicable to cloud? No, both of them you can do anywhere. In cloud, what do you mean by scale up? So now all my virtual machines or all my app services are running with, say, n capacity, and I upgrade that n to n+1 capacity, then it becomes scale up. So if I have currently I have 5 machines and I make it 10 machines, then it is scale out. So I can do both in on premises or on cloud. Clear? Coming back to things we had already discussed a bit earlier, infrastructure as a service abstracts the physical infrastructure layer and expose computing, storage, and networking as service. Unit of scale is operating system. Examples of IaaS include Azure virtual machines. We will see this again with some pictures from Microsoft from an exam perspective in module 1. But for now, make sure you understand the concepts well. Platform as a service, PaaS. Cloud provider takes care of a virtual machine and operating system, and developer is only responsible for the application. With PaaS, application is a unit of scale. Examples include Azure SQL database, Azure App Service, etc. Software as a service, software that is available on cloud as a service. Unit of scale is software. SaaS services include email, video streaming services, document sharing services, etc. So this is a quick comparison diagram. In on-premises, all these things are managed by customer. In infrastructure as a service, which is the first level of abstraction, virtualization, until virtualization, everything is the responsibility of cloud provider. Rest from patching OS or installing runtime, data applications, everything else is customer responsibility. With the platform as a service, everything including runtime is your cloud provider responsibility, and data and applications are yours. In software as a service, you are only responsible for configuring things. And also access, which is not mentioned here. If you write down your email password on the desk and then go to T, and when you come back, if somebody uses it and does something bad, you cannot complain that, okay, somebody, it is my cloud provider is not secure. As I mentioned, there are newer cloud service models than the traditional ones. One is identity as a service, then container as a service, then serverless. Under serverless, you generally have function as a service under serverless, but in Azure, no code or low code is also considered serverless. In serverless, you don't have to worry about the servers or runtime or anything. You just write your code or you create your logic, and rest everything is taken care by your cloud provider. And also another advantage of serverless is that in normal infrastructure service, even if it is a pay per use, do you think you can just pay for only whatever you use and then save money? Imagine that you are building a website, or you are the owner of a website like trainstone.com or cloudreach.com or qsantalk.com. like our shops, will you be able to shut down this website at night and go to sleep? Even in our class, we have people from a lot of time zones. We have people from UK, we have people from India, we have people from Australia, we have people from US, and we have people from South America, and we have people from Asia countries. And this was one time, this was one time which was kind of okay for everybody. So it may be a little bit late for some people, early for some people, midday for some people, but overall, this was one time we could okay for a session. But can I expect the same for people learning on their own times? No, right? So they will have their own time preferences. So I cannot switch off the website at night and go. That means my website has to run 24/7. So how many hours I will have to pay if I am using a virtual machine or a PaaS service? Tell me, per day. 24, right? But with serverless, I'll have to pay 24/7, right? It is like our 24/7 Zoom meeting in the contributors group. So most websites these days, especially because of Corona, people will be using it round the clock. So if people are using the website round the clock, then you have to run the website round the clock. But with serverless, you are not worried about that because you are only charged when your website is being used, or your APIs are being used, or your functions are being called, or your logic is being executed, or your database is being used. That means if you have no customers, you don't have to pay anything. How sweet is that? And also, when it comes to data storage on cloud, you'll have a file storage, you have a block storage, you have object storage, you have relational databases, you have non-relational databases, and also you have key value stores, you have document store, you have columnar store, you have graph databases. There are a lot of options that you can choose from in cloud. And many of these you will be learning in your future sessions or future courses. So if you are part of Forum CA, then you get to learn most of the things. So that is why I said the Forum CA will teach a lot of things, but plus you also need to learn from the community sessions to make it complete, because a lot of things comes through community sessions, a lot of things come through formal sessions. Cloud deployment models, public cloud, private cloud, and hybrid cloud. So public cloud is what we have been discussing mostly, what AWS, Azure, GCP, and all these cloud providers provide us. And also private cloud. What is this private cloud? It is having your own data center, but with features of public cloud such as automated and on-demand provisioning. So all data centers, all on-premise data centers are not a private cloud. Okay, so if it has the features of cloud such as on-demand and automated provisioning using some private cloud management software, then it can be called as a private cloud. And what is hybrid cloud? A combination of a public and a private. So public cloud, a user uses resources from a public cloud provider's data center. On-demand provisioning, pay-as-you-go pricing model replaces upfront capital expenditure with operational expenditure that can scale with business. Do not have to worry about physical hardware maintenance or hardware security. Benefit from the experience and purchasing power of a cloud provider such as AWS, Azure, GCP, etc. So that is also important, right? So whenever you are going and buying a server, so imagine that you are going buy one server, you get it for $100. And if you are buying 10, you get it for 80. And if you are buying 1,000, you get it for 50. So you need only one server. So if you are personally going and buying that server from market, you get it for $100. And if AWS is providing you, AWS is getting it for $50, or Azure is getting it for $50. So they are giving it for you at $75. Then it is a win-win for both the cloud provider and you, right? So the purchasing power of a cloud provider is also important when you consider pricing and costing. Okay, what is a private cloud? So brings the technology of a public cloud to on-premises. It's not same as traditional on-premises data center. It may be confusing as various vendors may define it differently. At least to get some idea, you can search and read more about Azure Stack or AWS Outposts. They come very close to or you can explore VMware softwares, VMware infrastructure management tools and software. That is where I was working until recently. What is a hybrid cloud? A combination of public and private clouds. Part of services may run on private cloud and part of services may run on public cloud. May use to extend private cloud with additional resources or services. So some of your data may be on premise, some of your data may be on cloud. So it could be based on various different things. One is your private cloud is getting filled, then you want to extend it to public cloud, or you want more services from public cloud. So there could be a number of reasons where you can work with these two together. And there are many networking components that are involved that will make sure that all these can work as or like a single unit. Even users from on-premises and public cloud can be synced together. There are a lot of advantages you can get from these hybrid cloud structure. And then with Azure, you also get many hybrid cloud discounts. If you have some on-premises licenses, you can make use of it and get discounts in your purchases on the public cloud. We have a lot of cloud providers: AWS, Azure, GCP, IBM Cloud, Oracle Cloud, Alibaba Cloud. Personally, I started with AWS, worked many years, written 2 books. One of them was specific to AWS, one of them covered Azure and others also. But for last few years, I've been focusing more on Azure because that is the trend, and then even the company I work needs me to work on Azure. So I always prefer to take trainings and sessions. I have been teaching for more than 10 years, but I always like to teach on topics that I use at work. That has 2 advantages. One, I can teach you things from my experience. And 2, I'll be more productive at work, because whenever I am teaching something, I definitely need to explore more things. I need to read, I need to prepare. Just based on my work experience, I cannot come here and take this class. Even preparing this presentation will take time, right? So the more I prepare, I'll be more productive at my work. And the more I am productive at my work, I can share more real world use cases with my students. So it is a win-win for both me, my students, and even the companies I work for. That is one of the reasons I train. And second, I get a lot of insights from these trainings, which help me write better books or blogs. So where does Oracle Cloud stands in the cloud providers? So Oracle is now catching up, but again, the first 3 is definitely AWS, Azure, and GCP. Out of that, based on market share, AWS is still the leader, but based on growth, Azure is the leader, and GCP is still lagging behind both these. So AWS and Azure is generally more common, and out of that, many of the corporates prefer Azure because they already have Microsoft partnership, and you get, so here you have more power to negotiate within Azure, because you don't have to even directly negotiate with Microsoft. You can negotiate with a Microsoft partner. So as all of you know, Trainso is a Microsoft partner. They can negotiate, get good discounts. They don't have to pay through credit card. They can have additional payment schedules or contracts directly with these Microsoft partners. And also, many of these people have a lot of existing Microsoft licenses, so they can make use of it. And also, when we learn about pricing, we will see that, okay, if for testing purposes, they don't have to pay a licensing fee. But if you are in AWS or other cloud, you definitely have to pay that fee. But costing is a very good topic to discuss. So we have a whole module to discuss. Even though it is Azure ghosting, we will touch upon AWS and other clouds also on that. So it depends. So because there are many factors, as I said, there is something called as a pricing for testing, a lot of things we will discuss. So simple example is Azure. If you have a Microsoft Windows license, so if you have if you have a virtual machine, you need to pay for Windows license as well as for compute. But Microsoft owns the Windows license, right? So Microsoft will say, okay, if you are using this for testing and development, don't give us licensing fee, only provide a computing fee. But other cloud providers won't be able to provide that because they'll have to pay Microsoft that licensing fee, right? So there are many factors when it comes to costing. So we will see them in detail in module 6. Okay, so now tell me, initially when I asked this question, how many of you are new to cloud? Some people said, okay, I am new. Some people said you are not new. Answer this question sincerely, honestly. Have you learned at least one new thing today? If yes, then it is worth both of our times. If no, then it is waste for both of us. From next class, we'll be going through syllabus. We'll be learning how things work in Azure, whatever we discussed today, and more. And we will also have meetings, not webinars, where you can interact with people in your batches, respective batches. Okay, so those sessions will be limited to AZ900 batch people, and also Forum C, because when you join Forum C, you can join any batch, any course, whatever takes or takes. Okay, so please at least note down whatever you heard today and read more and ask doubts, be active in community. And if you are really active in the community for just this 4 to 5 months, then you can really change how you play with knowledge. Okay, so if you attended yesterday's session, you heard people who have done this talk about this, right? So just be active, and you can all be experts in no time. And I believe this was a decent or good introduction to cloud computing for people with no background at all. And in the coming days, we'll be learning a lot more with respect to Azure Cloud, and a lot more with respect to other terminologies and concepts also. Practice regularly, ask questions, and also for some modules like module 3, we'll have something called as student presentations, where you will also have to present on a topic based on whatever you know, whatever you could find. So this is a program where you will not only get ready for certification, but you will be job ready for facing the market. So that said, we will wind up for now. Please also share your feedback within the respective groups or Facebook groups, wherever you are part of, so that we can spread the word, and then we can help more people. Okay, so people are afraid. Some people are afraid, thinking how it will be, but you have felt it, you have seen it, you have heard it. So with your help, we can reach more people. That's it. Bye bye for now. Be active in our groups, and see you all in next class.